This is Bob Capetta, and the lesson is on subsets. So what is a subset? Set A is a subset of set B expressed using this notation if every element in set A is also an element in set B. So let's take a look at four different sets. Set A, P, Q, R, S, T, U, V. Set B, P, Q, R, S, W. Set C, R, S, T, U, V. Set D, A, B, C, D, ending with X, Y, Z. So set D has all 26 letters in the alphabet. So looking at A and D. A, P is in D, Q is in D, R, S, T, U, V. They're all letters, so everything in A is in D. If everything is in A, everything in A is in D, we can say that A is a subset of D. And what is the notation we use? This is the notation that we use. Similarly, B and C. B is a set of 5 letters. C is a set of 5 letters. So, indeed, both B is a subset of D and C is a subset of D because all of the elements of B are contained in D. All of the elements of C are contained in D. Is C a subset of A? How do we check that? C contains R, S, T, U, V. A contains P, Q, R, S, T, U, V. R is in C. Is it in A? Yes, it is. S is in C. Is it in A? Yes, it is. T is in C. It's in A. U is in C. It's in A. V is in C. It's in A. All of the elements of C are also in A. So what do we conclude? Indeed, C is a subset of A. And how do we write that? C is contained in A using that symbol. Our next question, is B a subset of A? We need to look at all of the elements in B and ask if they are also in A. B. P is in A, yes. Q is in A, yes. R is in A. S is in A. W is not in A. So we found one element of B that was not in A. So indeed, P, Q, R, and S are in A, but W is not. If I have an element in B that is not in A, B is not a subset. It is not a subset of A. So the notation we use for that is we just draw a slash through the subset symbol. You'll notice I don't have the little underline there, and I'll explain that as we go along. But it's not a subset. We prefer this symbol without the underline. Is A subset of A? Sounds like a silly question. Are all of the elements in A also in A? Of course. Every element is a subset, every set is a subset of itself. So we check all the elements, and yes, of course, they're all in A. So indeed, A is a subset of A, but it is not what we call a proper subset of A. What is a proper subset of A? To be a proper subset, all of your elements have to be contained, but it's got to be different somehow. A is not a proper subset of A because it's not different. It equals A. So the notation that we use there, it's not a proper subset, but it is a subset of A. So what is a proper subset? And the symbol for proper subset is this symbol without the underline. Set A is a proper subset of B, expressed A is contained in B that way. If set A is a subset of set B and sets A and B are not equal. So to be a proper subset, you cannot be the same set that we're starting with. So let's look at some sets here. O, X is a natural number. Remember, natural numbers 1, 2, 3, 4, 5, 6, 7, ... and X is odd. E, X is a natural number, and X is even. A is the set 1, 2, 3, 4, 5. B is the set 102, 104, 106, 108, 110, 112, 114. C is the set 7, 9, and 11, and D is the set X such that X is a prime number. So we're going to look at this, and we're going to ask the following question. Of the listed sets, which are subsets of O? Well, let's start with O itself. Is O itself a subset of O? Well, everything is a subset of itself. O is a subset of O, but it is not a proper subset, right? O is not a proper subset of O because it equals itself, of course. How about E? Well, O is a set of odd numbers. E is a set of even numbers. Every element in E has to be in O. Certainly not the case, so E is not a subset of O. How about A? Let's see, 1 is odd, but 2 is not. 3 is odd, but 4 is not. 5 is odd. But as soon as you find one element in A that is not in O, it is not a subset. So 2 is in A, it's not in O. So A is not a subset of O. How about B? Well, these numbers are all even. 102, 104, 106, 108, 110, 112, 114. None of them are in O. So certainly B is not a subset of O, but B is a subset of something, yes. Looking at these sets, what is B a subset of? B is a subset of E. So I didn't ask that question to you, but I can go ahead and state that now. Now how about C? Set C consists of elements 7, 9, and 11. Is 7 in set O? Is 7 a natural number that's odd? Yes. Is 9 a natural number that's odd? Yes. Is 11 a natural number that is odd? Yes. All of those are true. So what do we conclude? We conclude that C is a subset of O. How about D? Is D a subset of O? Prime numbers. Do you know what a prime number is? So we're going to take a look at O and D. O is the set of odd numbers. D is the set of prime numbers. Is the set of D contained in the set of O? Is the set D a subset of O, or the set of prime numbers a subset of odd numbers? So what are prime numbers? In math, prime numbers are natural numbers greater than 1 whose only factors are 1 and the number itself. So 15 is not prime. 15 is 3 times 5. So I can find two interesting factors, not just 1 in itself, that make 15. It is not prime. So 15 is not in D, but it is in O. So we know right away these two sets are not equal. But 17 is prime, because the only way to build 17 is 1 times 17. There are not two integers, two natural numbers that multiply together to give me 17. So the question is this: are all prime numbers odd? 19 is prime, 23 is prime. Even numbers like 26, 2 times 13, 10, 2 times 5, 8, 2 times 4, 100, 2 times 50. So are all the prime numbers odd? That's the question. So we need to think about that. 3 is prime, 5 is prime, 7 is prime, 9 is not, 11 is prime, 13 is prime, 15 is not, 17 is prime, 19 is prime, 21 is not. Are there any even prime numbers? And the answer is yes. 2 is an even prime number. So are all prime numbers odd? Nope. 2. The only factors of 2 are 2 and 1. In fact, 2 is the only even prime number. But that is one number that is in set D that is not in set O. So we conclude that 2 is not an element of that set O. 2 is a prime number, but it is not odd. Therefore, the set D is not a subset of the set O. We find one element in the first set that is not an element of the second. Therefore, the first set is not a subset of the second. All right, we're going to look at the next discussion here. A is a set of X such that X is a person who works in Key West. B is the set X such that a person works in Florida. And C, the set X such that X is a person who lives in Florida. To be a set, it must be well defined. Are these sets well defined? What does it mean to work? What does Key West mean? These are more complicated questions than you would think. So for the sake of our discussion, let's say a person who works in Key West is a person who gets paid for doing some activity while in Key West. A person who gets paid for doing some activity while being in Key West. Same thing for working in Florida, a person who gets paid for doing some activity in Florida. A person who lives in Florida is trickier. What does it mean to live in Florida? It's not to be a tourist. A person who has a permanent residence in Florida. A person who files their taxes with a Florida address. A person who has a Florida driver's license. Well, this points out the difficulty sometimes with these ideas. What does it mean to live in Florida? So for the sake of discussion, let's say a person who has a permanent residence, who defines their permanent residence to the country as being in Florida. So we ask ourselves this question. Is A subset of B? Is a person who works in Key West, gets paid while doing a job in Key West, also a person who gets paid while doing a job in Florida? Well, since Key West is in Florida, I believe the answer to that is yes. What's our next question? Is B a subset of A? Is a person who works in Florida also a person who works in Key West? Well, a person who gets paid for doing a task in Florida, I have to believe we can find at least one person in Florida who has never been to Key West. If that person works in Florida, but if they've never been to Key West, they're not earning any money for doing a task in Florida, so that's no. How about, is B a subset of C? Is a person who works in Florida contained in the collection of all people who live in Florida? And I would say no to that as well. Because you certainly could be a person who lives on the border, near the border, maybe lives in Georgia or lives in Alabama and drives across the border to work. If I can find one person who works in Florida but lives out of state, that is also no. So those are just a couple examples we can look at. But again, if you're going to answer these questions, a set must be well defined. You've got to determine if someone is in the set or not in the set if you're going to do the analysis. Now, our main analysis here, our main discussion here is on subsets. And this may seem strange, but the empty set, the set containing nothing, and this is our null set notation, or empty set notation, is a subset of everything. So any set you can think of, the empty set is a subset of it. The emptiness is present in every set. Again, it seems like a philosophical more than a mathematical notion. And regarding proper subsets, as long as you're not an empty set yourself, the empty set is a proper subset of every non-empty set. So if I have my set A is P, Q, R, S, T, U, V, is the empty set contained in A? Yeah, it is. If our set is a person who works in Florida, well-defined set, a person who gets paid to do a task in the state of Florida. Same thing there, the empty set using this notation is a subset of that set. So the empty set is a subset of every set. The empty set is a proper subset of every non-empty set. So let's try to list all the subsets. So here I have a relatively simple set. It just consists of two elements, A and B. What are all of the subsets? Well, we just said the empty set is a subset of everything. So the empty set is a subset of this set. How about sets with one element? The set containing A would be a subset. The set containing B would be a subset. So those are subsets as well. So far I have three subsets of this set W, but I also have the set itself. W, which is the set of A comma B, is a subset. W is a subset of W. It's not a proper subset of W. But this portion of the lesson is going to focus on subsets. And this set has two elements and it has four subsets. So we're going to try to see if we can identify a pattern. Here I've got a set consisting of P, Q, and R, and I want to list all the subsets. Again, the empty set is a subset of everything. So the empty set is a subset that has 0 elements. How about sets that only have one element? Subsets with one element? Well, only P, only Q, only R. Those are subsets. How about subsets that have exactly two elements? Well, what would that be? P with Q, P with R, Q with R. So there's subsets with exactly two elements. And how about a subset with exactly 3 elements? Well, that's the whole thing again, P, Q, R. So this time we had 1, 2, 3 elements and 8 subsets. So can you identify what the pattern is going to be? Here it is. The number of distinct subsets of a set with n elements is 2 to the n power. Now one of them is all of them, right? Every element in the set. And that's not a proper subset. So if we want the number of proper subsets, we've got to subtract that one that includes everybody. So in this example here, we had 8 subsets, but 7 proper subsets when we throw out P, Q, R. So 2 to the n distinct subsets for n elements, 2 to the n minus 1 for the number of proper subsets. So let's take a look at a situation here. We have a set C, vegetables, broccoli, okra, cauliflower, green peppers, spinach. And we're going to ask ourselves the question, how many subsets does C contain, distinct subsets? Well, what do we have? 1, 2, 3, for 5 elements. So if we're looking at regular subsets, 2 to the 5th, or 32, 2, 4, 8, 16, 32 different subsets from this set. If we want proper subsets, we've got to throw out C itself. So 2 to the 5th minus 1, 32 minus 1, or 31 proper subsets for this set. Now I want to list them all, and I want to show you that indeed that's going to add up to 32 total. So the first question we ask, how many subsets have 0 elements? Well, there's 5 choices. If you want to think about them as pizza toppings, you want to choose 0 toppings, you get a pretty boring pizza. The empty set. So that's 5 choose 0. 5 choose 0 is just one subset. The empty set has exactly 0 elements. How about 1? Well, I've got 5 items. I'm just going to choose 1. So either just broccoli, just okra, just cauliflower, just green pepper, just spinach. Right. So 5 choose 1 subsets with 1 element, abbreviating by the first letter. There you have it again: broccoli, okra, cauliflower, green pepper, spinach. How many have exactly 2? Well, that would be 5 choose 2. So broccoli, okra, broccoli, cauliflower, broccoli, green pepper, broccoli, spinach, okra, cauliflower, okra, green pepper, okra, spinach, cauliflower, green pepper, cauliflower, spinach, green pepper, spinach. So 5 choose 2, 10 of those, and again, there they all are. So we had 1, then 5, then 10, so we're up to 16 with 0, 1, or 2. How about 3? If I choose 3 of these, it'll be 5 choose 3. 5 vegetables, I'm going to choose 3 of them. How many subsets have exactly 3? That's 5 choose 3, which is also 10. And there they are, if you want to look at it. How many have exactly 4? Well, if you have exactly 4, you're leaving 1 out. How many ways can you leave 1 out? Just 5. So 5 choose 4 is 5 subsets. 5 subsets with 4 elements. And then how many subsets have exactly 5 elements? Well, there's your 4 elements. If I have 5 elements, what are we going to say? That's just all of them. That's not a proper subset, but it is a subset. Yes. So broccoli, okra, cauliflower, green pepper, spinach, all 5 are there. So let's count them. 1 plus 5 is 6, 10, 16, 10, 26, 5, 31, plus 1 more to make you 32. So 32 subsets, 31 of them are proper subsets of an original set that had 5 elements. And what did we say our rule was? Our rule was 2 to the 5th elements for number of subsets. So 2 to the 5th is 32. I don't know what that is. That is definitely a typo, so we'll get rid of that. 2 to the 5th minus 1, 32 minus 1, 31 proper subsets for the total number of proper subsets. 2 to the n minus 1, 2 to the 5th minus 1, 31 proper subsets. And that will conclude this lesson.